The learning objectives for this class are to identify the characteristics associated with aircraft's center of gravity and to identify the steps used in determining the location of the center of gravity on an aircraft. What exactly is center of gravity? Center of gravity, or CG, is the point about which an airplane would balance if it were possible to suspend it at that point. It is the mass center of the airplane, or the theoretical point at which the entire weight of the airplane is assumed to be concentrated. It is usually expressed in inches from the reference datum. An airplane is designed to have stability, so it will maintain straight and level flight. Longitudinal stability is maintained by ensuring the CG is slightly ahead of the center of the lift. As long as the CG is maintained within the allowable limits for its weight, the airplane will have adequate longitudinal stability and control. If the CG is too far aft, it will be too near the center of lift and the airplane will be unstable, and could result in loss of control. As long as the CG is maintained within the allowable limits for its weight, the airplane will have adequate longitudinal stability and control. This produces a fixed nose-down force independent of the airspeed. This is balanced by a variable nose-up force, which is produced by a downward aerodynamic force on the horizontal tail surfaces that varies directly with the airspeed. If the CG is too far aft, it will be too near the center of lift and the airplane will be unstable. At the low stall airspeed, there may not be enough elevator nose-down authority to get the nose down for recovery and difficult to recover from a stall. If the unstable airplane should ever enter a spin, the spin could become flat and recovery would be difficult or impossible. If the CG is too far forward, the downward tail load will have to be increased to maintain level flight. At slow takeoff speeds, the elevator might not produce enough nose-up force to rotate, and on landing there may not be enough elevator force to flare the airplane. Both takeoff and landing runs will be lengthened if the CG is too far forward. In this video, we will identify whether the CG was too far forward or too far aft based on its flight characteristics. The airplane took off and pitched up at a very steep angle. As it continued to climb, it stalled and was uncontrollable. These are indications of the CG being too far aft. It was determined that the cargo load shifted rearward while the airplane was being catapulted and caused the CG load to move too far aft. Every aircraft has a pilot operating handbook or information manual. It contains important weight and balance data that will assist you in determining the center of gravity and adjusting weight distribution as needed. The first step in determining the CG will be to list all the weights. In determining the CG, we will also determine the gross weight of the aircraft. It is important to be as accurate as possible listing the weights as they will affect the location of the CG. In this case, our Cessna 152 has front seats and 2 baggage areas. The airplane weight is documented on the weight and balance record in the airplane. After we list the weights, they are added together and entered in the total. In the Pilot Operating Handbook, we find the section in the Weight and Balance chapter that shows the loading arrangements. The CG arm is also referred to as a station. Note 1 tells us that the arm for the fuel is station 42. The front seats are station 39, and baggage area 1 is at station 64. List each arm or station next to its corresponding weight. The formula to calculate each moment is weight times arm equals the moment. We will do this for each line. The resulting moment is divided by 1000 before being recorded. We then add the moments together and enter the total. Also located in the weight and balance section is a chart that shows the center of gravity moment envelope. First, we find our loaded airplane weight in the left side of the graph. Our weight is 1,635 pounds. Each line in the graph for the weight represents 20 pounds. Our weight is slightly below the second line above 1,600 pounds. Next, we find our moment on the bottom of the graph. Each line between the numbers represents a half pound inch. Our moment is 54.5 and is located on the first line to the left of the 55 line. Now, with our weight and moment marked, we follow the weight line to the right and the moment line up until they both intersect. In this case, they intersect within the outlined area, which tells us that we are within the limits of the center of gravity for this airplane for takeoff. It is also advisable to calculate the CG for landing, since most of the fuel will be gone and the weight and CG will change. If we are not within the CG limits, we may be able to redistribute the weight closer to the datum. This will reduce the arm and moment. If that doesn't help, our only choice is to remove weight from the airplane until we are within limits. Can you identify the correct formula? The correct answer is C. Weight times the arm equals the moment. In summary, we have identified the characteristics associated with aircraft's center of gravity, and we also identified the steps in determining the location of the center of gravity on an aircraft. This is one of the many subjects you must know and understand in order to become a proficient pilot. Reference this class as needed to maintain your knowledge and fly safe.